Architecture can be viewed as a textbook or a snapshot of its time and place. It is often a product influenced by existing technology, and thereby it becomes a historical and cultural production. In the words of Lewis Henry Morgan, quote, architecture is the printing press of all ages and gives a history of the state of society in which it was created. A brief look at the different technological revolutions over the past 500 years can reveal how Western architecture has been influenced. It is only in this last decade of the 20th century that a new revolution began with the birth of digital technologies. In the midst of the revolutionary products, architecture has been at the forefront of, say, historical and cultural productions. There have been obvious shifts in architectural priorities and conceptions throughout these revolutions. For instance, each of the three modes of making, such as pre-mechanical, the mechanical, and the digital eras, all had three modes of visual recognition, whether they be handmade, machine-made, or if they are essentially virtually made. They have all been affected by these technological revolutions in some way. So this paper will identify how each mode of making and visual recognition has affected architectural design. Each method of production will be evaluated by its benefits and challenges to the profession. The pre-mechanical mode of creating traditional architecture was focused on beauty and aesthetics, craftsmanship and handmade quality, long-term use and durability. It produced a sense of, say, visual similarity, but not of identicality due to the authentic human touch. Arnold Berliant offers the following insights regarding the relationship between the handmade mode of making and its visual recognition of similarity. Quote, one can, with little difficulty, single out features that are typical of art objects of the past, features that arise in large measure from the fact that these articles were produced by such skilled craftsmen using relatively simple hand tools. Such objects combined workmanship that was intricate, a design unique to the object, and rarity and expensiveness that were the result of the large quantity of labor required to produce a small output. Because of their manner of production, he continues, traditional art objects possess signs of human workmanship and fallibility, displaying considerable irregularity and providing maximum opportunity for unstudied, intuitive decisions in the process of fashioning them, close quote. So according to Berliant, he illustrates why these pre-mechanically produced objects are discernible due to their direct contact with the creator's hands. There is no doubt that the focus of the pre-mechanical age was on the authenticity of the craftsman's hand. Likewise, the architectural profession was traditionally regarded as a craft, or close to the notion of a craft. One of the benefits pre-mechanical production, therefore, one of its benefits stems from the maker's direct three-dimensional relationship to the object. Due to the amount of time and energy required to produce objects in traditional or artisan cultures, they were created with a focus on long-term use and durability. But embedded within an object's handmade quality was also the aura of authenticity, simply from being an original work of art resulting from painstaking efforts of honest manual work. Architecture and art were both marked by age, authenticity, and permanence, while at the same time having a sharp distinction between art and utility. In many ways, architecture was speaking the same language as the handwritten manuscript, the hand-shaped pottery, or etched gold coins for thousands of years. And it is in this historical setting that there were benefits to having the architect serve as a master builder, since collaborative engagement with multiple trades at the construction site was crucial for success. Evidence from this period can be seen in the classical temples of Greece, in the pyramids of ancient Egypt, the Forum of Rome, the flying buttresses of Gothic cathedrals, or even Brunelleschi's dome in Florence. None of these lasting architectural monuments would have been possible without a cyclical and collaborative design-build process. One final important benefit arising from an embodied mode of production, vis-a-vis the hands, eyes, and mind, is the transmission of wisdom, knowledge, and poetic content through the art of building. Architecture has the ability to serve as a non-literary text or a non-literary vehicle, conveying meaning and messages that preserve both a cultural and historical memory of a specific place and time. Quote, "The history of architecture is a history of built ideas," writes Alberto Campo Baesso. In order to transmit symbolic meaning through buildings, pre-mechanical architects needed both technical and practical knowledge acquired from the arts and sciences. In fact, our oldest treatise on the subject by the Roman architect Marcus Vitruvius Pollio says that architectural education required knowledge of many branches of study and varied kinds of learning. He insisted that in order for architects to acquire influence and attain their purpose, any theoretical foundation and semantic knowledge of architecture had to be carefully grounded in pragmatic knowledge gained from manual labor. For Vitruvius, architectural education was a balance between acquiring manual skill and scholarship, practice and theory, making and thinking. Pre-mechanical production prevented a disconnect between the architect's body and mind. Some of the challenges arising from pre-mechanical production dealt primarily with the amount of time that was required to produce a handmade object. Consequently, there was usually an increase of cost due to the greater time needed to build or produce the object. Likewise, the ability to reproduce objects and create exact replicas with an aura of visual sameness was nearly impossible prior to the mechanical age. Lastly, the architect's ability to gain a balance between theory and practice to imbue architecture with symbolic meaning would take many years. Studying a plethora of multidisciplinary subjects, as suggested by Vitruvius, and mastering another trade such as sculpture or painting, as evidenced in the Renaissance, would also take time. The extensive length of time was due to the training and education an architect underwent, as well as following the pattern of the medieval craftsman guilds, where one moves up through the ranks of apprentice, journeyman, and finally on to becoming a true master. The transition from the pre-mechanical age to a mechanical focus shifted priorities from visual similarity to visual sameness, from the craftsman's hands to the machine, and from long-term durability to short-term consumption. What the book is to literacy, architecture is to culture as a whole, writes Dalibor Vesely. Architecture shift from a pre-mechanical production emphasis on visual similarity to a mechanical production aimed towards visual sameness marked not only a new era, but a new society and culture. This change was instigated by the technological and cultural productions of the Renaissance and later refined during the Industrial Revolution. The mechanical age of production, with its focus on identicality or the making of identical copies, brought several benefits to the design and construction industry. In particular, the 15th century's arrival of the printing press and Leon Battista Alberti's notational system for architectural drawings both played an important role on the mass production and transmission of architectural information. Friedrich Kittler suggests that the need for pictoriality was as defined as the ability to reproduce pictures of saints, was at the origin of the printing press. The focus on reproducing images allowed sciences such as engineering, botany, architecture, and mathematics to progress. These disciplines needed to show things rather than merely talk about them, which was utterly impossible before the invention of graven images. The arrival of the printing press not only reduced the cost of reproducing written texts and images, but it sped up production time by eliminating the process of hand copying manuscripts. Indirectly, however, it opened a way for the unrestricted distribution of information. This unhindered circulation of ideas to a broader audience of society resulted in a cultural revolution. It is in this typical techno-cultural feedback loop, argues Mario Carpo, that machine-made identical copies prompted a cultural awareness of identical reproducibility for architecture. This was key in disseminating technical architectural information. According to Carpo, printed images were put to task to illustrate visual models of famous buildings, old and new alike, but also to disseminate new illustrated catalogs of architectural components, both structural and decorative. One of the other benefits emerging from the Renaissance was derived from Alberti's process for architectural design, where architects were encouraged to stop making things and rather design things instead. Alberti tried to convince architects to leave their outdated role as the master builder and embrace the new ideal of being the master designer. Alberti builds upon the Platonic notion that architects are not workmen or carpenters, but rather the rulers of the workmen. It is in this light that architects began the slow process of working indirectly with their objects by turning their focus to a notational system of scale drawings, codified as plans, elevations, and side views outlined in Alberti's second book. According to Mario Carpo, quote, Alberti's entire architectural theory is predicated on the notational sameness between design and building, implying that drawings can and must be identically translated into three-dimensional objects. In Alberti's theory, he concludes, the design of a building is the original, and the building is its copy. The technological innovations of the Industrial Revolutions all had varying effects on the standardization of construction methods, building materials, communication, material transport, manufactured building components, and architectural design. Inventions such as the steam engine, telegraph, and telephone spinning and weaving machines, electric generators and lighting systems, camera and the photograph, processes for mass production of steel, and internal combustion engines all helped expedite the ability to achieve a sense of identicality in architecture through mass production. As witnessed in the printed book, mass production and industrial standardization created economies of scale for architecture when building components were comprised of a series of standardized machine-made elements, parts, and pieces. This thinking carries over even into today's practice where buildings are assembled from a kit of pre-manufactured parts from various vendors per the architect's drawings and specifications. All of these efforts are designed to speed up construction and save money. Despite the benefits of mechanical production on architectural design, several challenges arise with this mode of production. The architectural conventions of plan, elevation, section, and perspective became a way to accurately represent a scaled-down version of a three-dimensional building. Because of the focus on two-dimensional architectural drawings, however, Renaissance buildings took on a paper-like or flat quality with a focus on frontality, as evidenced in Alberti's design of Santa Maria Novella. Architecture became a process of translation. Lines transfer with alacrity from paper to stone, and the wall becomes a petrified drawing. Alberti's insistence on the architect's drawings also results in a detached relationship to the construction site and a loss of collaboration. The focus on the notational systems of architectural drawing eventually led industrial technologies to push for an architecture marked by simplicity, economy, uniformity, quantity, ocular centrism, precision, and functionalism. As Mario Carpo claims, mechanically reproduced objects and forms are indexical of the imprint that made them, but most handmade, pre-mechanical, and algorithmically produced items are not. Close quote. The mechanical mode of reproduction sought visual sameness and bore the stamp of identity, uniformity, and authority. In this setting, the architect relinquished their role as master builder to become the master designer. The architect now worked indirectly with an object through two-dimensional representation, while the pre-mechanical architect worked more directly with the object. Another challenge of industrialized societies who pushed for standardized machine-made objects and processes is the transformation of craftsmen in guilds to essentially assembly line workers in factories. As machines become more optimized, they not only replace the hands of skilled artisans, but entirely put them out of work and out of business, argues Leon Creer. The paradox of an industrial society, he continues, is that, quote, the availability of handwork decreases and the cost of handwork rises in direct proportion to the number of unemployed hands. History reveals that the rationale for standardization, industrialization, and totalitarian abstraction have not always been undertaken with the best intentions, especially for National Socialist architecture. According to Adolf Hitler's decree, quote, building elements have to be largely normalized. Work on building sites has to be mechanized in order to eliminate artisan work as far as possible. One has to find methods, he continues, which will allow an essential simplification and acceleration of the building process, close quote. Several of these methods and arguments emphasizing the primacy of production over art originated with the fathers of modernism, namely Walter Gropius and Le Corbusier. Hitler's efforts, however, were all aimed at the speedy reconstruction of bombed cities, using exclusively industrial construction methods. As summarized by Hitler's architect, Albert Speer, once the entire sequence of construction is reduced to an industrial logic, it becomes a matter of numbers and quantities, miles and millions, series and clones, close quote. Another one of the challenges arising from a mechanical mode of production is the need for architecture to appear mass-produced. Colin Davies argues that since architecture has a moral duty to express the, quote, spirit of the age, high-tech architecture must embrace industrial technologies. The fact that architecture must embrace, the fact that machines are usually mass-produced, he continues, and made of synthetic materials such as metal, glass, and plastic, he asserts, buildings should follow suit and use like materials, even if it's not the most economical solution. Even if buildings cannot be mass-produced or even assembled from mass-produced components, he concludes, they should at least look mass-produced, or at least be capable of repetition. Beyond its emotive quality, these arguments do not adhere to an ethical functionalist perspective, but instead resort to a form of architectural deception. The emphasis on an industrial aesthetic lends itself to short-term consumption, reduction of skilled labor, unnecessary expenditures, and the production of waste. The digital revolution, however, has been going on as we shift our attention since the 1970s. But its impact on architectural design arrived several decades later. In many ways, the digital revolution has helped silence this modernist philosophy of identicality and visual sameness by turning its focus to non-visual variability and algorithmic procedures. Under digital production, one finds that objects are virtually made prior to their physical manifestation. The digital revolution shifts its focus from identicality because it becomes meaningless and worthless in a digitized environment, where recognition depends on more complex patterns of cognitive perception, argues Mario Carpo. As in most modes of production, the digital era brings with it several benefits for architecture. The emergence of computer-aided drafting, or CAD, in the early 1990s, for instance, shifted architects away from pen, pencil, and paper to keyboard, mouse, and screen. James Ackerman has compared the emergence of this technological innovation as being on the same level of importance as the introduction of paper itself. Quote, here the machine does not merely accelerate drawing processes that previously had been carried out only by hand, he explains, but opens up a potential not attainable on the drawing board, one with extraordinary opportunities for the extension of architectural form, close quote. In search of the lost aura of authenticity espoused from mechanical reproduction, the computer is viewed by some as having a salvific purpose for reclaiming architecture's authority. From the arrival of CAD, the tools of the architect to communicate their design intent have continued to expand, from augmented reality, cloud-based collaboration, 3D printing, photorealistic renderings, parametric modeling, simulation, big data analytics, computational design, and building information modeling. You can see that the palette of tools at the fingertips of architects enables them in some ways to reconnect with the pre-mechanical age when the architect was the master builder. This time, however, it is in the digital realm of mathematicized space. As Mario Carpo illustrates, quote, digital technologies act as an almost organic rather than prosthetic extension of the hand of the maker. These digital tools lead to faster architectural production and virtual prototyping, among other things. The non-visual variability of the digital revolution, however, does pose a challenge greater than what the early stages of mechanization had meant for modern architecture, explains Antoine Picon from Harvard University. For the first time, perhaps, architecture has to confront itself with a deeply non-tectonic reality, since the design of information networks obeys principles that are profoundly different from the conception of buildings, he explains. Consequently, the tactics of modern eclecticism found in the deconstructivist and blobitectural works of architects such as Frank Gehry, Zaha Hadid, Daniel Libeskind, Greg Lynn, Bjarke Ingels, and Tom Main display an avant-garde emotive quality from this non-tectonic language. Many of these architectural works would have been difficult to produce without the assistance of certain advances in digital technologies. Architects in this category typically renounce all historicizing forms in favor of uncertainty from their lack of a unified perspective. With such an emancipatory stance from history, some architects have even been so bold to declare that drawing is now dead. Digital production does not come without its own challenges. Some skeptics question the efficacy of replacing the hand of the architect with machines. Quote, architecture cannot divorce itself from drawing, no matter how impressive the technology gets, contests Michael Graves. Drawings are not just end products, they are part of the thought process of architectural design, he explains. From neurological and haptic connections between the eyes, mind, and hand, to serving as a mnemonic device to improve our recollection, the creative act of drawing is important for not only the design professional, but also for the non-artist. While the computer has its benefits in expediting architectural production and virtual prototyping prior to building construction, it has its most drastic consequences on the early phases of the design process, argues Juhani Palasma. For instance, quote, computer imaging tends to flatten our magnificent multisensory and synchronic capacity of imagination by turning the design process into a passive visual manipulation, a retinal survey. He continues, the computer creates a distance between the maker and the object, whereas drawing by hand or building a model puts the designer in skin contact with the object or space. Computerized architecture tends to read as repulsively plastic, unreal, immaterial, digital, and sharp-edged. Buildings that fall into this category typically fail at relating back to the human body and corporeal experience because they are stuck in the digital realm and become industrialized kitsch. According to Palasma, quote, as buildings lose their plasticity and their connections with the language of the body, they become isolated in the cool and distant realm of vision. With the loss of tactility and measures and details crafted for the human body, and particularly by the hand, architectural structures become repulsively flat, sharp-edged, immaterial, and unreal. The detachment of construction from the realities of matter and craft, he continued, further turns architecture into stage sets for the eye, into a scenography devoid of authenticity of matter and construction. The sense of aura, the authority of presence that Walter Benjamin regards as a necessary quality of authentic pieces of art, has been lost. Close quote. Digital production seems to follow the effects of Albertian ideals for mechanical production by further separating design from construction and the mind from the hand. Other challenges arising from scientific rationalism that are carried over into digital production are the rejection of the past and its historical precedents, cultural memory, and canonical forms. A zeitgeist approach to architectural design that distances itself from the past in favor of novelty, ephemeral pleasurability, consumable iconographic individualism, and unmediated industrial production leaves us yearning for an authentic culture, which was once rich in myth, argues Dimitri Porphyrios. Architects of today have in some way lost touch with the phenomenological or experiential approach to architecture, with its connections to tactility, craft, nature, and myth. One might say this is in large part due to the lack of an existential understanding of the world from being trapped in virtual mathematicized space. As T.S. Eliot wrote, where is the life we have lost in living? Where is the wisdom we have lost in knowledge? And where is the knowledge we have lost in information? Each of the three technological revolutions have taught us about the different modes of making architecture and their manner of visual recognition. While each mode of production has its benefits, there are also challenges associated with each method that must be addressed as we consider the future of architecture. Let me conclude with 3 axioms for the making of future architecture. Design with beauty, defend the authentic, and build for time. Designing with beauty requires humility from the architect to engage with and learn from the past. Breakthroughs in evidence-based design, neuroaesthetics, and environmental psychology are holding architects to a higher level of accountability regarding the effect of beautiful architecture on well-being. One way to regain meaning and beauty in architecture, along with its symbolism and poetic content, is to once again embrace a living mythology by adopting a phenomenological lens through which to view the world. An existential understanding of the world could be restored by observing the immutable mathematical laws of natural phenomena, now embedded in subdisciplines such as biomimicry, or perhaps returning to the Renaissance cosmology, where number and geometry were a link between the human and the divine. This is argued by Alberto Perez Gomez. Philosopher Carsten Harries also recently encouraged the architectural profession to, quote, reappropriate the wisdom buried in the traditional understanding of architecture as repetition and image of the cosmos, close quote. Discerning the harmony, patterns, proportions, order, geometry, and spatial relationships inherent in nature is key for architecture to remain in collaboration with history and tradition. Quote, meaningful buildings arise from tradition, and they constitute and continue a tradition, explains Juhani Palasma. No architect worthy of his craft works alone. He works with the entire history of architecture in his bones, close quote. Next, defending the authentic. A need to defend the authentic is tied to the loss of the aura inherent in an original, authentic, handmade object that was brought on by mechanical production. Instead of succumbing to the aesthetics of speed, newness, innovation, and industrial kitsch, architects can defend the authenticity of human experience by honoring and preserving the spirit of a place, its culture, traditions, memory, and history. Architects must focus on the Vitruvian principles found in pre-mechanical modes of production, such as balancing theory and practice, scholarship and manual workmanship, thinking and making. Although architects are immersed in a digital culture, they must resist the urge to immediately jump into a computerized design process. Instead, they should focus on the tactile and embodied nature of working with their hands in order to develop manual skills, internal imagination, and refine their craft. This is best in the early phases of design through physical model making and drawing with one's hands. Without returning to the body, the dematerialization of cultural expression from the digital information age will continue to take over, attests Julio Bermudez and Robert Hermanson. Architects from the digital age must learn to deal with the interface between the physical and the virtual rather than focusing almost exclusively on the latter, explains Antoine Picon. This is not to say innovative digital tools are to be completely rejected, but they should be viewed as means to an end instead of ends in themselves. And lastly, build for time. The shift from long-term use and durability to short-term consumption and industrial waste during the era of mechanical production forces architects to reevaluate the ethical function and sustainable use of materials in their designs. Instead of giving into the contemporary aesthetics of consumerism, architects need to return to pre-mechanical production's focus on durability, longevity, weathering, and the adaptive reuse potential of buildings. Building for time requires the architect to view their work as an architectural craft that requires manual skill, training, imagination, experience, personal commitment, and judgment. Quote, the tradition of craftsmanship is clearly gaining increasing value and appreciation in today's reality of the technological world, mechanical production, and the regrettable loss of the touch of the human hand in our mechanically mass-produced products and environments, writes Juhani Pallasmaa. Instead of reducing skilled labor and increasing unemployment by a lack of traditional materials, intricate details, and architectural ornament, architects should work to incorporate branches of traditional crafts and trades relating to architecture and building into their projects. Thereby, architects might champion the return of the traditional craftsman, painter, sculptor, artist, and artisan. Building for time also requires the architect to retain their connection to the construction site, the realities of building, and those who are bringing their designs to life. It is through a collaborative effort with hundreds of surrogate hands that the architect executes his or her work. Consequently, explains Pallasmaa, the architect must remember that collaborative craftsmanship requires mutual respect for the special skill and experience of the craftsman executing his design. Building for time, therefore, is a form of environmental stewardship and wise resource management that prevents short-term consumption, the reduction of skilled labor, and unnecessary expenditures, and the production of waste. So what then is the role of the architect in today's digital culture? Their role is one of respectful collaboration with the craftsman to build for the long term. They use technology to facilitate modes of making without letting the digital realm overtake authenticity, tactility, and manual skill. And lastly, they preserve the memory, meaning, and poetic content of human experience by respecting culture and tradition, beauty and harmony, thinking and making. Thank you very much.